Dr. S. Tamarai Selvi is working as a professor in the Department of Computer Technology, MIT campus of Anna University, Chennai. She has over 30 years of teaching experience. Grid computing, cloud computing, and e-learning are her areas of interest. She has successfully completed 12 research projects funded by Government of India and Tamil Nadu state government. She has established Center for Advanced Computing Research and Education and acquired 1 patent and has filed for 3 more patents in her research area. She has presented over 110 papers in international conferences and published 45 papers in international journals. She has authored 5 books. The latest book is titled Mastering Cloud Computing, published by Morgan Goffman Publishers 2013.
Welcome to UGC lecture series on cloud computing. We are discussing about the virtualization, and in the previous episode we have discussed the basic concepts of virtualization, and in this episode we are going to see some examples of the hypervisors which are going to be useful to create virtual machines. Before starting this session, I wish to acknowledge the various persons as well as the organizations, because I have taken most of the slides from the various resources. First, I wish to thank the DIT New Delhi Government of India for sponsoring our Center for Advanced Computing Research and Education, and through that research lab we have gained a lot of experience. Then I have selected the slides from various organizations such as Google, IBM, HP, Oracle, Citrix, Cisco, etc., and also the slides given for Zen, VMware, VirtualBox, KVM. I have taken some from the internet resources, and also for the SDN, software defined networking, I have picked up the slides from Professor Nick McEwan, who is the actual contributor of this SDN, and the slides are very interesting, and that is why I have picked up as such, thanks to Professor Nick McEwan. And also for storage virtualization, I have picked up the slides from University of Manchester. Really it was given with a crisp concept, that is why I have picked up from there. For the sake of completing various virtualization concept, I have covered both the network virtualization and storage virtualization in depth, and also our thanks are due to VMM developers, then various books, journals, conference papers related to virtualization also we have referred to, and in general internet resources, because some of the slides I have simply picked up from the various resources. That is why I wish to specially thank all these organizations as well as the professors for sharing the slide with this UGC lecture series. So, I have considered the different VM platforms such as VirtualBox, Zen, VMware and KVM. In the last episode, we have discussed about the different hypervisors and also what is the principle behind the hypervisor. The hypervisors are nothing but virtual machine monitors, and what are the principles behind the virtual machine monitors, everything we have discussed along with the types of virtualization as well as different advantages. Now, if you want to further proceed in the virtualization, it is essential to simply install some of the virtual machines using your laptops or using your personal computers, so that you will be understanding how it is working, at least what part of this virtualization may be known to you. It is quite simple, and lot of tutorials are available and lot of instructions are given regarding the installation of the various hypervisors. Just as an example, I have taken only a few, so that you will be knowing the architecture of these VMM as well as the procedures to install these hypervisors to create the virtual machines. So, first let me take VirtualBox. So, VirtualBox is also one of the hypervisors developed by product from the Oracle Corporation. It provides the full virtualization support for x86 hardware, and you can have Windows operating system or Linux operating system or Mac operating systems or various Linux flavors. For all those operating systems, you can have the VirtualBox as the hypervisor. Now, when you want to install the VirtualBox, it is very simple procedure. Even though I am going to show you some of the snapshots of the installation procedure that will help you to just understand the installation procedure. And what I want is the learner has to separately spend about half an hour or 1 hour time to install this VirtualBox in his or in her laptop or personal computer. It is a easy procedure and all the instructions are self explanatory. Just for the sake of completion, I have included the slides showing the various steps of installing VirtualBox. So, you have to follow the procedure as given in the next few slides, and you can follow the setup options as well as selection of the suitable configurations whenever it is asking. And everyone may create the VirtualBox in a PC or laptop to experiment the virtual machine. Now, you take your machine in which you can download the VirtualBox from the given website, that is virtualbox.org/wiki/downloads, or even in the Google search, if you put VirtualBox downloads, you will be getting the particular URL. And once if you download it, it is stored in the machine. In your machine, you are having this actual downloaded file. Then the downloaded file should be double clicked, so that you will be getting this window and you can just click the run button. Once if you click the run button, it will start the installation of the actual hypervisor, and you will be getting this particular wizard, that is you will be getting welcome to the Oracle Virtual Machine VirtualBox setup wizard. So, you can click the next button, and once if you click it, it will be asking to select the features to be installed. What are the features you want to select? All those things you can just pick up and then you click the next also. And once if you click the next button, you will be getting the next other features to be selected and then go to the next one. Now, you are getting the various interfaces given here. You can click yes for setting the network interface. Once if you give that particular yes for the previous one, then you will be getting this particular screen. Here you can click the install button, and after the installation you are getting the particular screenshot and it will start installing that particular hypervisor. Now, you can have the VirtualBox being installed, and once if you install that, you will be getting the shortcut for that VirtualBox also. And now, you click this created shortcut for the VirtualBox. Then it will show the VirtualBox interface, and at this leftmost end you will be seeing the button new. Next, you can just click the new button to create the virtual machine template. So, by clicking it, you will be getting the virtual machine template shown. So, in the virtual machine template, you will be getting the another dialog box for which you have to give the name of your virtual machine. So, for that purpose, just you can use the name Ubuntu server. So, if you give that and if you type it, then you can go to the next screen. Now, it will ask for the memory size for your virtual machine. So, you can give the memory size as 512. So, you can adjust this one so that how much memory you want to give, that can be automatically visible, and you can set the actual requirement of your memory. So, it depends upon the system in which you are installing your virtual machine. If the memory is more than 4 GB and all, you can have it as 1 GB or 2 GB also. If it is 2 GB machine, just you can have 512 as the RAM size for your virtual machine. Then you have to give the virtual hard drive facilities. So, you should show that what is the actual thing you are selecting, that you can give it. It is essential to select the file type of the virtual hard drive, that also you can select out of the given options. Then you have to select the physical hard drive. Here you are having dynamically growing as well as you are having a fixed one. Two types are there. You are fixing it as fixed one. Fixed one means once the virtual machine is fixed with some hard drive capacity, you cannot expand it. Suppose if you just take the dynamic provision, automatically it will be expanding or shrinking. So, both are available. Then give the hard disk space as per the requirement, since you have made it as fixed one. Here the size can be simply increased or decreased by having the actual button available here. The default size of the hard disk space is 8 GB. So, whatever you want based on the availability of your physical machine's hard disk space, you can just fix the size of the hard disk space. Now, you are creating the virtual hard drive. After fixing all those things only, the virtual hard drive is actually created. Then the virtual machine template is successfully created, and you have to start the virtual machine by just clicking the start button. You are having the start button here. Now, you can click the start button. Then you will be getting the VirtualBox information. You proceed with the next one and click the file browser as shown in the screen. Once the file browser is given, then you have to select the operating system location in the system as given here, and after selecting the operating system location, now you have to install the operating system following the normal procedure as we are doing for the physical machine also. So, we are having the operating system installed successfully. Now, you can log into the created virtual machine, and as usual you can work in this virtual machine as you are working in the physical machine. So, when you make use of the hypervisor, first of all that hypervisor is downloaded, then you are following the various setting up options for fixing the RAM size as well as hard disk capacity also. Then after successful installation of your hypervisor, then you are creating this virtual machine, and also once the virtual machine is created successfully, you have to install the operating system. So, the installation of operating system is to be followed after the creation of the virtual machine, because the virtual machine is not having the operating system as such, but if you are having some virtual image which is created with some sort of operating system already embedded as an image, then that will be bundled with the OS also. In that case, simply you can start the particular virtual image after creation of the virtual machine, and your bundled operating system will also be opened and you can directly log into the virtual machine. So, the purpose of this procedure is just to make the learner to understand the simplicity of the steps followed in installing a particular hypervisor. See, whatever may be the hypervisor you are using, you have to simply follow the steps given in the tutorial or instructions manual given for that particular hypervisor. Everything is available in the internet. So, at least any one hypervisor of your choice you can pick up and install the particular hypervisor and create the virtual machine by setting up the requirement of the RAM as well as hard disk capacity, and also install the operating system. Finally, you will be getting the virtual machine created. Before the next episode, I request the learners to make an exercise to create one virtual machine, so that you will be able to understand the other episodes in an easier way. So, this completes the VirtualBox installation. Let us have a short break now. Welcome back after the break. Now, we are going to just discuss about Zen. That is, Zen is also another hypervisor. first of all, I wish to introduce the different terminologies used with Zen. There you will be using one terminology called domain 0. This is the first domain and it is privileged to manage other domains also. Unprivileged domain is nothing but any domain other than domain 0 and cannot manage other domains. Then you are having another domain called driver domain. It is a domain that contains the physical drivers and usually this is just domain 0. Then physical driver, the device driver that talks to the hardware, usually it is in the driver domain, and the virtual driver, it is the device driver, usually in a domain U means domain 1 or domain 2, like that you can give the numbers after creating domain 0, and it fulfills the request by going to the physical driver. So, these are the various terminologies being used in Zen, and you can think of domain as a container for running a virtual machine. So, you can assume that this domain is a container for running a virtual machine. So, this is the Zen architecture taken from the Zen website only, and here you are having the hardware part. Then second one is, this is the actual virtualization part. So, you are having the domain control interfaces, virtual CPU, virtual physical memory, then you are having the virtual network, then virtual block devices. So, all those things you are having. This Zen is creating the virtual resources from the physical hardware, and you are having this control plane software which is actually the Zen our device drivers. So, normally the domain 0 will be having all those things, and you will be having the other user software installed over the guest OS. So, everything will be having its own domain and you will be using a virtual machine for each guest OS. So, you can have the Linux version or you can have the BSD version or you can have the XP version of all those things. Now, if you consider this one, this domain 0 is the first domain which is created whenever you install the hypervisor, and that is the actual booting software for other domains to be created. Now, in this architecture you are having the domain 0 which is managing the entire virtual machines created. So, you are having the physical hardware at the bottom and you are having the physical drivers also. Whenever you are having other domains created, say domain 1, domain 2, etc., there again you will be having your kernel IO system and here you will be having the virtual driver, and above that you will be having the applications. Now, the various managements of the IO as well as other things are done through hypervisor using domain 0. So, you are having the data lines meant for this Zen enabled communications, and the physical hardware is available here. So, how it is communicated with the physical hardware? That is with the help of the hypervisors. So, with the various directions are given for mentioning the flow of the signals as well as the instructions in the Zen architecture. So, Zen uses para-virtualization. Already we have discussed what is para-virtualization. It is the actual technique where it modifies the kernel of the host OS. So, whenever you install the para-virtualized hypervisor, the host OS gets modified, and here the guest operating system is modified to run in parallel with other modified systems also. The main advantages are the performance is better and also it is open source, and the disadvantage is the hosted operating system must be modified before it can be hosted by Zen hypervisor. Sometimes if you are using a licensed software, it is very difficult to modify the host operating system. So, in that case it will be a problem. And the capabilities of Zen, when you consider, the base OS of the machine is called the domain 0 and it runs the hypervisor, and Zen guests are referred to as domain U. However, many of them are there, and live migration of guest domains from one domain 0 to other is possible. So, live migration is supported by Zen hypervisor, and you are having I/O as well as CPU throttling. That is, machines can be allocated a percentage of total I/O and percentages of CPU usage. So, you can assign the percentage of the existing available resources by using the Zen, and Zen source claims that this makes them denial of service proof also. Now, it is possible to create the virtual machine using Zen also. Those who are interested, you can create Zen virtual machine also. Now, the Red Hat Linux, Scientific Linux, these are all bringing the actual Zen as part of it. So, by using the virtual manager, it is possible to create the virtual machine. See here, already the Linux version of Red Hat and Scientific Linux, they are coming along with the actual hypervisor domain 0. So, it is running 8.27% of this one, and the memory usage is also given. Now, this virtual machine manager can be used for creating your new virtual machines, and whatever is created, that can also be viewed here. Now, this is installing Zen machine via the Red Hat Kickstart. So, by using the Red Hat Kickstart, it is easier to create the virtual machine, and you have to select the languages, follow the procedures given in the actual manual. You can easily install the virtual machine, and the procedure is briefly given. You can install the normal Scientific Linux version 4 or 5 in your machine, then get the Zen binary tarball from zen.org, then you make install. This gives a Zen modified kernel, and adjust the grub and reboot your machine with Zen kernel. That grub is the boot loader. So, you have to reboot your machine with that Zen kernel, and you take a known good OS to install. Then you have to rsync it into the partition of what is going to be your root install for the Zen machine, and modify the network files appropriately. So, these are the procedures to be followed. Actually, earlier versions were taking lot of efforts to configure this and that. Those who are not familiar with the Linux administration, they may face some difficulties in installing these things, but those who are working in Linux machines, it is very simple to install, and you can have the various configurations as requested. When you consider the Zen networking, see, this is the basic concept. The domain 0 is here, domain 1 is here. You are having the physical Ethernet card in your physical machine, that is P80, and it is possible to create so many virtual Ethernet by using the actual ETH0, and you are having the virtual files 0, 1, 2, 3, any number you can create it, and MAC address is also given for the domain 0. From that, for each machine it is possible to create. So, two major ways to get network access from Zen instances to the outside world. One is bridging, right, as shown in the left, and another one is network address translation NAT, and another one is host. These are the three types available. Whenever you are having the bridging, it is possible to have the link through local area network also, and within a campus you can have such things, bridging the various nodes created by means of virtual machines. Then NAT is useful whenever you want to access some virtual machine outside your organization. So, through internet it is possible to connect your VMs created, and you are having the networking configuration using NAT. Host means you are having your own machine, there you are creating your virtual machine, and it can be accessed only by your own machine, it cannot be connected to anything else. So, you are having host, NAT, bridging, these three types of networking you can just configure. And zensource.com was founded to market the hypervisors, and Citrix, that is the organization, took over the Zen, and it happened in the year 2007. Their main goal is to market turnkey Zen appliances and special purpose hypervisors. So, in Zen, if you want to just recapture the various things, the guest operating system is the actual operating system that the Zen hypervisor hosts. The domain is the virtual machine under which a guest operating system executes. So, guest OS is equal to a program and domain is equivalent to a process, like that you can just understand it. So, a hypervisor is that is, when you consider the hypervisor, a particular Zen version which handles low level functionality. So, these are the various things we have studied under Zen. Then next one is KVM, that is also another popular virtual machine which is coming under open source, and many of us are using this KVM for so many practical applications. So, kernel based virtual machine is a Linux kernel module that turns the Linux into a hypervisor. By having this KVM, it is possible to turn the Linux OS as the hypervisor itself, and it requires hardware virtualization extensions also, and it has the support for multiple architectures such as x86, 32-bit as well as 64-bit, then S390 mainframe, PowerPC, then Itanium, and so many other architectures it supports, and it is tightly integrated into Linux operating system. So, when you consider the overview of the KVM's architecture, you are having the x86 hardware, then Intel means VTX, and AMD, that is, you are having the AMD V. So, these are the various virtualized architectures available supported by the processors from Intel or AMD. So, you are having the Linux kernel in which you are having the KVM module, and it is possible to create virtual machines in a single machine. So, KVM is the kernel based virtual machine which supports full virtualization solution for the Linux operating system, and it has been incorporated into the Linux kernel in the year 2006, and it converts Linux into a hypervisor, and it runs the unmodified operating system as guests. So, if you see this architecture, you can easily understand how it is working. You are having the hardware at the bottom layer, then you are having the Linux kernel which is having so many device drivers for the actual physical devices in the system. Then you are having a KVM module, and you are having quick emulator, QEMU is quick emulator. So, once the KVM module is initiated, that quick emulator is actually configured, and using that it is possible to create various guest operating systems. So, this is the fundamental principle of KVM, and if you want to compare the different hypervisors, say for example, KVM, Zen and VMware. Now, you can see the actual architectural diagram. So, above the hardware you are having the Linux kernel in which the KVM module is also available. Then using that KVM module, quick emulator is actually installed, and you are having this untrusted guest created out of that KVM. Similarly, if you take Zen, here you are having the x86, above that you are having Zen. If you install Zen over Linux, means that Linux gets modified and you are getting Zen as the operating system sitting over the hardware. Then you are having the domain 0 Linux kernel, then using the domain 0 it is possible to create so many guest OSs. If you take VMware, you are having the actual hardware at the bottommost layer, then you can have Windows or Linux operating system over this, and above that you are having the workstation or GSX server, and using this workstation or GSX server you are able to create the virtual machines like this. So, you are having the hardware layer, above that OS layer, above that you are having the hypervisor. So, VMware is sitting above this, and you are having the other ESX server as well as GSX server. Two types of servers they are using in VMware. So, how to create the virtual machines using this one? Whenever you are having ESX server, that ESX server is sitting above the hardware itself, that is why it is definitely more effective or it is faster than this workstation based thing or GSX server based virtualization. So, when you consider the KVM, it is possible to run the multiple virtual machines running unmodified Linux or Windows images, and each virtual machine has the private virtualized hardware, a network card, disk, graphics adapter, everything is available. So, we have discussed about the installation of the virtual box and also the installation procedure for Zen hypervisors. So, these two hypervisors can be easily installed in your system, and before coming for the next episode, please experience the installation of any one of the hypervisors. And also I wish to answer the following questions. You have already known some of the hypervisors. List out any two hypervisors which uses the para-virtualization concept. Then differentiate between para-virtualization and full virtualization. Next, who has developed VirtualBox? The next question is, what is the Microsoft hypervisor available in the market? Just you can refer to the internet and find out the answer for all such questions. Thank you.